Basic electrical engineering. In our previous video, we are learned about the resistances in series and resistances in parallel, and we are able to calculate the equivalent resistance of resistances in series and parallel. In this video, we are going to learn about the resistances in series and parallel combination of both combination. So let's see the equivalent resistances in series. If the resistance is one end is connected to another end of the resistance, then it is called series connection. Here the three resistances are connected in series. Apply Ohm's law across each resistance. Then V1 is equal to I R1, V2 is equal to I into R2, V3 is equal to I into R3. The total voltage is the sum of individual voltages across each resistance. So IR is equal to IR1 plus IR2 plus IR3. Next, cancel this i's. Then R is equal to R1 plus R2 plus R3. This is a relation when the resistances are in series. This is the equivalent resistance when the resistances are in series, where R1, R2, R3 are connected in series. I is current flowing in all the resistance. V is applied voltage. V1, V2, V3 are voltage across each resistance. Finally, total resistance is sum of the individual resistances. This is the conclusion about our resistances in series. We learned this and do some numerical problems in our previous classes. Next, let's see the resistances in parallel. Here the resistances are in parallel, R1, R2, R3. So the total current is divided into individual loops. Then I1, I2, I3 are the individual currents of R1, R2, R3. So the total current I is what? The combination of I1 plus I2 plus I3. According to Ohm's law, I is equal to V by R. Substitute the value of this. Then I is equal to I1 plus I2 plus I3. Substitute the value of I1, I2, I3. Then V by R1, V by R2 plus V by R3 is equal to V by R. Take the common value of this V and cancel on both sides. Then finally we are getting 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, like that. If it has n resistance, then this is a equivalent resistance. formula. Here in parallel, the voltage is same. The potential difference across every resistor is same, but the current is divided into different resistors. In series, current is same. Only single current is flowing in the circuit. In parallel, voltage is same. Let's see the comparison of this series and parallel circuits. Circuit current is the same in series circuit. Voltage is the same in parallel circuit. In series circuit, the total voltage is the combination of all the voltages, the sum of all the voltages, V1 plus V2 plus V3, like that. Here in parallel circuit, the total current is sum of the remaining individual currents. I total is equal to I1 plus I2 plus I3, so on. Total resistance RT is equal to R1 plus R2 and so on. Total conductance GT is equal to G1 plus G2, so on. Here I is equal to V1 by R1 or V2 by R2, like that. V is equal to I1 by G1, I2 by G2, like that. This is the comparison of series and parallel circuit. Up to now, we are learn about the series circuits of the resistances and parallel circuit of the resistance. Sometimes we need our circuit as neither pure series nor pure parallel. In that cases, we may be required for the combination of series and parallel circuits. So we have to, most probably this type of circuits are also used in our electrical circuits. So our next concept is what? The combination of series and parallel circuits. The combination of series and parallel circuit is as shown in this figure. Here R1 and R2 both are in parallel. Then this combination is in series with R3 resistance. For every resistance if we are having the more resistances, we have to take its equivalent resistance to simplify our circuit. Here we have to simplify our circuit. What is the way to simplify this? Here we know that R1 and R2 are in parallel. So instead of R1 and R2, we write its parallel equivalent circuit. R1 into R2 by R2 plus R3. That equivalent parallel equivalent circuit is series of this R3. Here this is R equivalent. For first parallel combination, we have to this is a R3. we have to find this equivalent of this pair. What we do? This equivalent RE is R1 into R2 by R1 plus R2. Instead of connecting, taking these two resistors, we will take only single resistor. It is replaced by its equivalent resistance. How to calculate this equivalent resistance? Here our circuit is parallel combination. That's why R1 into R2 by R1 plus R2. Then instead of writing this, we are writing here as R suffix E. Now this RE and R3 are in series. So what is our final answer here? Our final answer is RE plus R3 gives our total resistance, R total. So instead of writing, connecting or taking three different resistances, we are replaced with one single resistance. Its value RT is RE plus R3, where RE is R1 into R2 by R1 plus R2. Okay. Next, let's see the example. A resistance of 30 ohms is connected in parallel with a resistance of 60 in series with the parallel combination. A 20 ohms resistor is connected as shown in this figure. So what is the total resistance of this entire circuit? This is the question. Okay, here what we have to do? We have to find its equivalent resistance. Let's observe this circuit. Here this 30 and 60 are in parallel combination. So we have to find its parallel resistance. So R equivalent is what? Here 30 into 60 by 30 plus 60. Then we get here this is a 20. We have to find its equivalent. So R equivalent is 30 into 60 by 30 plus 60. We will get 20 ohms. Now these 20 and our series resistance 20 are in series. In series, what we have to do? We have to add this. 20 plus 20 gives 40 ohms. This is the final answer. This is the final answer. So instead of this three resistances, we replace with single resistance in our circuit. So that by doing this type of thing, we are simplified our circuit, and sometimes the cost of the circuit is also reduced. Here if we are using this individual resistances of 30, 20, 60, we are replaced with a 40 ohms resistance. Then our circuit complexity will be less and cost of the circuit will be less, and it is very simple to understand and to observe also. So this type of benefits are added when we are replaced the resistances with a simple equivalent resistance. That's why we have to learn to calculate the equivalent resistances. Here, two resistances. Here, two resistances are in R1 and R2 are connected in series across 100 voltages supply. Take a current of 5 amperes, and when they are connected parallel across the same, take a total of 33. This is the total current. Find their values. Here the given data is the series is of 100 voltages. Two resistances are taken. This is R1 and R2 are the two resistance. When they are connected, they are taking 5. When they are connected in parallel, they are taking 33 amperes. What is the value of R1 and R2? Interesting question. Just read one more time this question, then you will understand this. Here, two resistances are there. R1 and R2. When this combination is connected in parallel, then its current is 33. When these two are in series, R1 and R2 are series, then its current is 5. Depend upon the values, the current values are changed. The supply voltage across this is 100 voltages. So what is the value of this R1 and R2? This is the question they are given. Okay. We have to solve this. In this, first take the series combination. R1 and R2. The voltage supply is 100 volts. This is a circuit. Here I is there given as 5. So according to Ohm's law, I is equal to V by R. So ikkada R is what? R1 plus R equivalent is R1 plus R2. So here R1 plus R2 is 100 by 5. This is the equation we are get. R1 plus R2 is 20 ohms. This is the case of series connection. Let's look the case of parallel connection. Here this is the R1 and R2. In this, the voltage source is 100 and the current is 33. In this circuit, according to Ohm's law, I is equal to V by R. But here instead of R equivalent, what we are write? R1 into R2 by R1 plus R2 is equal to what? V by I. Substitute the values of this V by I. 100 by 33 gives 3.33 ohms. Right? Then finally what we get? R1 R2 is equal to by R1 plus R2 is equal to 3.33. But according to our previous equation, what is this R1 plus R2? R1 plus R2 is equal to 20. Replace this value. Then we will get our R1 into R2 is equal to 3.33 into 20 gives what? 60 ohms. Here we are taking the formula of A minus B whole square. R1 minus R2 is equal to R1 minus R2 whole square minus 4 into R1 R2. By taking this, we substitute the values. Then R1 minus R2 we get it as here our formula is R1 minus R2 whole square is equal to R1 plus R2 whole square minus 4 R1 R2. Here this is plus, not minus. By our first equation we are getting as R1 plus R2 is what? 20 square minus 4 into, in our second equation R1 into R2 we get as 60. Then 400 minus 240. R1 minus R2 square is equal to what? 160 ohms we will get. Root of this 160 is 12.6 ohms. This is the next equation. I hope this is the third equation. R1 plus R2 is equal to 20 is the first equation. R1 minus R2 is equal to 12.6 is the next equation. Solve these two equations, then finally we will get the answer. See, this is the two equation. Then finally we get the answer of R1 plus R2 is equal to 20, R1 minus R2 is equal to 12.6. By using these two equations, we are able to solve R1 and R2 values. Let's see the next problem. Here this is a circuit. Find the total resistance and total current of this circuit. In this figure, let's observe the combinations. 3 and 4 are in parallel. 2, 8, 6 are in parallel. First, we find its equivalent resistances of 3 and 4 and the equivalent resistance of 286. Then combine these two equivalent resistances. Those are in series. Then finally we get the answer. Let's try to solve this problem. Let's see the steps. Here 3 and 4 ohms are in parallel. So 3 into 4 by 3 plus 4. Here For this combination we are getting 1.7 ohms. This 1.7 ohms is in series with the remaining circuit. Let's solve this. Right? Here 2, 8, 6 are in parallel. 2 into 8 into 6 by 2 into 8 plus 8 into 6 plus 6 into 2. Then our RBC gives 1.263. Here total resistance is combination of this RAB plus RBC. RAB value is 1.7. RBC value is 1.2. The final answer is this. In this way, we are calculate our equivalent resistance of the total circuit. The next bit is we have to find the total current. The total resistance value we are find. In that given data they are given the voltage is 20. According to Ohm's law, I is equal to V by R. So 20 by this 2.9 gives the total current value. It is 6.75 amperes. In this way, we have to calculate our equivalent resistance. Mostly, we have to find its equivalent resistances by solving resistances are in series and some resistances are in parallel. Then we simplified our circuit. Now, let's see the division of current in parallel circuits. Here, this is a next topic. In parallel circuits, the voltage is same. The total current is divided into these branches of R1 and R2 resistances. So, we take it as I1 and I2. So, I is a combination of I1 and I2. Let's see the different methods to solve these currents. How this total current is divided into these individual branches. This is the first method. Here, in this first method, potential difference across each resistor is same. V is same. Current in the circuit of R1 is I1. Current in the circuit of R2 is I2. So, I1 is equal to V by R1. I2 is equal to V by R2. Divide the equation 1 with equation 2. Then I1 by I2 is equal to R2 by R. Here the point observed is the current is inversely proportional to their resistance. And also another point what we are observed, the total current is divided, means I total is the sum of I1 plus I2. In this equation I2 is equal to I minus I1. From this equation 3, if we want I1, then R2 by R1 into I2. We can write this also. But according to the previous, instead of this I2, we are right here the value of is instead of I2. I2 we write it as I minus I1. Simplify the equation. Take the things in an appropriate order, then I1 into R1 plus R2 by R1 is equal to, finally we get this equation. So totally I1 is I into R2 by R1 plus R2. Next I2 is equal to R1 by R1 plus R2. We have to remember these two equations. What is it? I1 is equal to I into its opposite resistance R2 by R1 plus R2. Like that, I2 is equal to total current into its opposite resistance R1 by R1 plus R2. So I1 is equal to total current into its opposite resistance by sum of the resistances. Like that, I2 is equal to total current into its opposite resistance by total resistance. Why we call it as opposite resistance? See, I1 it's I1 its opposite resistance is R2. I2 its opposite resistance is R1. That's why we remember it easily as I1 is equal to total current I into its opposite resistance by sum of the total resistances. This is the first method. Let's see. By using conductance also, we are calculated this method. G1 is equal to 1 by R1 and G2 is equal to 1 by R2. I1 is equal to Vg1 and I2 is equal to Vg2. Here G1 is equal to 1 by R1 and G2 is equal to 1 by R2. I1 is equal to Vg1 and I2 is equal to Vg2. or divide these equations, then I1 by I2 is equal to G1 by G2. The current in each branch is directly proportional to its conductance. When three resistances are connected in parallel, so here same voltage source is applied. R1, R2, R3 are in connected in parallel. First method. In this, current in the circuit of resistance R1 is equal to I1 and the resistance R2 is I2. Current in the circuit of resistance R3 is I3. This is a circuit diagram. In our previous year, just taking the two resistances only, that is a current division rule for these two resistance. I total is equal to I into its opposite resistance by total resistance. I2 is equal to I into its opposite resistance by total resistances. So this is a way to calculate when the two resistances only are in parallel circuits. This is a rule for current division. Here this method is only for the two resistance. Let's see if there are two or more. If we connected three resistances are in parallel, then what will happen? Here I is the combination of I1 plus I2 plus I3. Its total sum. I1 is equal to IR by R1. I2 is equal to IR by R2. I3 is equal to IR by R3. It is the equivalent resistance. I1 is total current into its opposite resistances. What is the opposite resistance of this I1? R2 and R3. This product of R2 and R3 by sum of its products. R1 into R2 plus R2 R3 plus R3 R1. Next I2. I2 is equal to total current I into its opposite resistance R2 R3 by R1 R2 plus R2 R3. I3 is equal to I into R1 R2 by R1 R2 plus R2 R3 plus R3 R1. Next, second method. In this second method, 1 by R is what? G. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. G is equal to G1 plus G2 plus G3. Therefore, I is equal to V into G. I1 is equal to V into G1. I2 is equal to V into G2. I3 is equal to V into G3. Just divide this equation 1 and 2. From equation 1 and 2, I1 is equal to this and I2 is equal to this. Mostly we use the first method. Just let's solve the problems. Find the current in each branch of the circuit given below. So this is a question here. 28 2.8 ohms and 3 ohms resistors are connected in parallel, and the combination is in series with the 7 ohms resistor. This is the question. To solve this question, here we are using the current division rule. So first we have to calculate the equivalent resistance of RAB. Here this 2.8 into 3 by 2.8 plus 3. This gives 1.45 ohms resistors, and it is in series with 7 ohms. So what is the total resistance? Total resistance is 8.45 ohms. So our intention is to find the total current in 7 ohms resistor. So according to Ohm's law, I is equal to V by R. So V by this 8.45 gives 0.71 amperes. Now what is the question? In this question they are asked to calculate the I1 and I2 values. For I1, what is the formula? Total current I into its opposite resistance by sum of the resistances. 0.71 into its opposite resistance, what? 3. 3 by 2.8 plus 3. Here this is I1. Its opposite resistance is 3. So total current is 0.71 just 2. Now we are finding its opposite resistance 3 by total resistance 2.8 plus 3. This gives a complete current value. Like I2. I2 we have to calculate it as total current I into 0.71 into its opposite resistance. I2 opposite resistance is what? 2.8 by 2.8 plus 3. This is a value for I1 and I2. So by using the current division rule, we are able to calculate this problems. This is the most probably this type of methods are come in our competitive exams also and your semester exams also. This is very much important. Just see one more time. Find the current in each branch of the circuit given below. This is a thing. Here I is divided into I1 plus I2. These two are in resistances in parallel, and the equivalent resistance is in series with the next resistance, right? In this, just for finding this equivalent resistance, we calculated here as 2.7 into 3 by 2.8 plus 3 gives a 1.45, and this equivalent resistance is combined with this 7 ohms resistance. Total RAC is RAB plus this also. Then we are getting the total resistance as 8.45. So to find the total current according to Ohm's law, what we have to do? I is equal to V by R. Here in this they are given the data as V is equal to 6 and its total resistance we are calculated as 8.45. So I is equal to V by R, right? By using this formula, Ohm's law, we are calculated the value of current. Now we are getting our total current. Here the question is, find the value of I1 and I2. So I1 is I into total resistance by sum of the resistance. Like that, I2 is equal to total current into opposite resistance by total resistance. By using these two, we are able to find the I1 and I2 values of currents in individual branches. This is a application for our current division rule. So in this video we are learned the problems related to numerical problems related to series and parallel combination, and to find its equivalent resistance to simplify the circuits, and current division rule, and some more numerical problems. Hope you may solve some more problems available in your textbook also. Practice makes us perfection. These are very much important problems. It is comes under your semester exams and competitive exams also. This type of problems only they are given from our electrical part. So you have to solve few more problems in your textbooks. Right. Thank you, and thank you for watching this.